Hello everyone, welcome to Geology Concepts. I am here to discuss with you the MCQ section of IIT-JAM 2022 paper and will give you the brief solutions of the paper. So let's start. The first question you had as per the master question paper, that which one of the following is a geochronologic unit. So if I go by the options, first one is system, which is a chronostratigraphic unit. Period is actually the geochronologic unit, and member and formation both are stratigraphic units. So the correct answer here will be the period. Next question says, which one of the following must have thickness less than 1 centimeter? So if I happen to arrange these in the order of thickness, so I will place stratum, which is the thickest, then layer, then I have beds, and then finally the lamina or laminations. So this is specifically is something which is less than 1 centimeter or 10 millimeter. Hence my correct answer here will be the lamina. These were very few simple questions. Next is based on the extinction of important organisms which got extinct at the Cretaceous Tertiary, or we can say Mesozoic Cenozoic boundary. So the correct answer here will be ammonite. Trilobite got extinct in Permian, and both of these are still living. Next is from the geomorphology, simple match the column. So if I happen to match these, cirque is a geomorphic feature related to the glacial geomorphology. Ventifact on the other hand is aeolian environment. Point bar is from fluvial, and tephra is a volcanic feature. Hence my correct sequence here will be 2, 4, 1, 3, which is option number A here. Going forward, I have a question from igneous textures. It asks which one of the given textural features results from exsolution. Now exsolution is actually the unmixing of two solids. So this is a very prominent feature in the albite orthoclase solid solution, in which at lower temperature they both tend to unmix in a solid solution, and they form perthitic and antiperthitic kind of textures. Hence the correct answer here will be perthitic. Next is from crystallography. It says in the holosymmetric class of the cubic system, holosymmetric meaning the normal class which has the highest symmetry, how many more faces does the 110 family of planes have compared to the 111 family of planes? Now as it's a family of plane, because it is mentioned in the curly braces, I will have multiple planes in this particular family, and because it's a cubic or isometric system, I can have 12 such combinations of these intercepts. To give you a few, I can have 110 plane, I can also have 101 plane, or I can have 1 bar 0, so forth and so on. So I will have such 12 planes. You can try all the possible scenarios yourself, and similarly in this case I will have 8 such combinations such as this, and so forth and so on. So I can clearly see that the number of faces in this particular family of planes are 4 more than this one. So the correct answer here will be Bombay, which is 4. Which one of the following seismic waves involves compression and rarefaction but not rotation? It should be irrotational of the material that it passes through. So it's clearly the primary wave. As you can see here, the motion is actually in the direction of the propagation of wave, in which the energy is being transferred by alternating compression and rarefaction of the material. Whereas in the shear or S wave, material or particles are polarized in a perpendicular direction to that of the travel direction of wave propagation. Hence the correct answer here will be the P waves. Next is the difference between realgar and orpiment, which both of the minerals are of arsenic element. So few of the properties of these minerals are same, but they can be clearly distinguished on the basis of color. As you can see here, that real gar is reddish to orange, whereas orpiment is yellowish. You can see luster is same, and even the hardness of these is same, and the fracture is also same, which is sectile. So the correct answer here will be C. Next is from the structural geology. Buccal folds result from. So buccal folds are a type of fold which form due to layer parallel shortening, in which due to the competency contrast between two beds, there is such kind of folds are developing, and the wavelength of these folds are actually proportional to the competency contrast between these beds. Hence the correct answer here will be the layer parallel shortening of the bed. Sandstone beds above a magmatic body, which, or we can say Pluton, are domal in shape, such as this, while the beds below are horizontal. So the magmatic body is clearly, you can see the beds are domal here and flat at the bottom, hence this feature is laccolith. Next is match the column from paleontology. So you have to match these morphological features with their corresponding fossil groups. So we can see pedicle foramen is a feature from brachiopods. Paleal sinus is actually a prominent opening in the bivalves, which is represented by Pelecypoda here. Pygidium is present in trilobite, and siphuncle is present in cephalopod. So the correct sequence of the match should be 4, 3, 1, 2, which is in the option number A. Next, the Triassic-Jurassic boundary lies within which one of the following stratigraphic units? Now, one thing that is common in all of these formations is that they belong to the Gondwana sequences found in India. All of these belong to Gondwana, and I have put a chart over here of all the stratigraphic formations of Gondwana basins in different parts. So as you can see, we have to identify this boundary between Jurassic and Triassic, which you can clearly see is being represented by Dharmaram formation here. So the correct answer here will be Bombay. You can see Panchet is slightly lower. Panchmadi is also not present at that boundary, and Denva is also far away from that boundary. So the correct answer here will be the Dharmaram formation. Next is a very simple question from the Bowen's reaction series. Which one is the correct order of stability of minerals when arranged from most stable to the least during chemical weathering? So if you remember the mafic series of Bowen reaction series, discontinuous series, which is olivine, pyroxene, amphibole, biotite, then you have orthoclase here, muscovite, and then finally quartz. So this is the mafic series of the Bowen reaction series, and if I go up in this series, I get the minerals in the direction of least stability. So I have to arrange these in the most stable to the least stable state. So hence I can see the quartz is most stable here, then I can see muscovite, then amphibole, and then olivine. So the correct answer here should be C. Next is from sedimentology. I have a few sedimentary rocks and their compositions. P and Q are limestones, and R and S are sandstones. So you can go as per your wish. I find sandstone classification more easy, so let's do it that way. I have a vacay and an arenite. So the basic difference between arenite and vacay is that the matrix content. So if I have matrix content more than 15%, I will surely have the vacay, and arenite is not a possibility. So clearly I can see S is matched with the 2, hence I can rule out 2 options here. Now the only option for sandstone is 1, hence I got my answer as R equal to 1 and S is equal to 2. But if you can see, Paxstone is a limestone in which it's a grain supported and also contains mud, but grain stone is something which is grain supported but it contain a very less amount of mud or no mud at all. So the correct answer here will be A. Next is from the dimensions of few physical parameters such as shear modulus. So shear modulus has a unit of equal to pressure, which is Pascal, we can say. And if I try to write down its fundamental basis, so I can write Pascal is actually nothing but force per unit area. This is nothing but Newton per meter square, and Newton is nothing but kilogram meter per second square, and I have a meter square here. So meter square is cancelled by a meter, so I am left with kg second square meter. Hence if I want to write it in terms of dimension, I can write it as mass 1 time or length minus 1 and time minus 2. So for shear modulus, at least I can say fourth option is the correct one, and if I can calculate this one, I can easily write the answer because it's only in the one option. Then you have a dry density or density, which is nothing but kg per meter cube. So it's very simple that it's mass 1 and length negative cube, and it does not have a time dimension. So this way you can do it, and the correct answer here will be A. Hydraulic conductivity has a unit of meter per second, which is velocity, and volumetric strain is, we can say, dimension or unitless, because it's just delta V upon V, in which both of the quantities have the same dimension or same units. Hence the relating dimension for this will be M0, L0 and T0. Next are few features or few places and their seismic activities possible. So you can go with the easiest one. We have Nepal in our country, or close to our country. So we know Nepal is actually sitting on this continental collision between India and Eurasian plate. So I can easily write R as 4, which I can find in 3 of the options. But apart from this, I can see Iceland has a mid oceanic ridge going very prominently between or through this. Then Indonesia is having this subduction zone. It's also not far from the India or Indian subcontinent. It's towards the east of India, we can see. And New Zealand has this transform fault going along this continent. So the correct answer here will be A, which says P is 3, Q1, R4 and S2. Next is from earthquake seismology. It says which of the magnitude scales does not saturate while estimating the size of earthquakes. Now here I want to clarify this. What does saturation mean? See, there are a lot of different type of magnitudes, and the reason for having a lot of magnitude at the first place is that all of these magnitude scales get saturated when larger size of earthquakes are being calculated because of their restrictions or limitations to the quantities by which they are being calculated. But the only magnitude of estimating the size which does not get saturated is the moment magnitude, which is represented by MW, and which is calculated using the seismic moment M0, because this is something which is actually related or being calculated based on the actual properties or actual scenario of the earthquake, such as the rock or the shear modulus of that rock in which the earthquake has occurred, the area of slip or the slip itself. So this is something which can give you the best possible results in a large earthquake, such as we had one in 2004 associated with the tsunami. So it was a 9.4 9.5 earthquake, magnitude earthquake. So it was calculated using the moment magnitude scale. So this is the one which does not get saturated. All of these things I have taught in the class, so I hope at least my students would have done it correctly. Alright, next question. The apparent dip of a plane is measured to be 45 degrees towards northeast. Okay, so this is the scenario. This is your northeast, and some bed is having a dip or apparent dip towards northeast. The true dip of the plane is. Now the first thing is that if the apparent dip is 45 degrees, the true dip cannot be more than 45 degrees. Hence sorry, it cannot be less than 45 degrees. Hence I can rule out two options clearly here, B and D. Now I'm left with the A and C. Without having the strike direction, I cannot actually calculate the amount of dip, but using the sense of or direction of dip, I can certainly say which direction is the possible true dip can be. So if I say this, suppose this is my bed, so in all of these possible directions my true dip can be, but in any of these directions true dip is not possible. And if you can see, the south southwest, which is something like this, is one of the possible or one of the options which we can easily rule out. Hence the correct option here will become C. So your true dip can be in this direction and is of course more than 45 degrees. So the correct answer here will be C. A horizontal upright fold will have a, so you have this Fluties classification here. All of these have been taught in the class quite in detail, so I hope all of you might get it. So you have this horizontal upright fold somewhere here which looks like this, in which the axial plane is perfectly vertical and the fold axis is quite horizontal. So you can see, if you look at this horizontal upright fold, you can see the horizontal fold axis and vertical axial plane. Hence the correct answer here will be Bombay. Okay, next is again from structural. It says the displacement of the bed shown in the figure is caused by a single movement along fault XYZ. So this is your fault plane XYZ. Out of these given options, which fault type can explain the observed displacement? Now this is a type of dip fault. What is a dip fault? Dip fault is a fault in which the strike direction of fault is in the direction of dip of bed. So this is I can write it here, strike of fault is in the direction or is in the dip direction of regional beds. So now if you can see, the regional beds are dipping in this direction. You can see they all are dipping in this direction, and you can see the fault plane has a strike in this direction as well. So this is for sure a dip fault. Now there are two methods by which you can actually say whether it's a normal, reverse or strike slip fault. So if you just look at this cross section, you can easily say that it's a normal fault, because this is your foot wall and this is your hanging wall, and the hanging wall has moved downwards with respect to the foot wall. You do not need to look at the map view, it's just given to confuse you. So the correct answer here will be normal, which is quite evident from the cross section. But just to be sure, just have a look at this sequence of figures, in which just the only difference from our actual figure is that the fault is vertical. Our fault is dipping in this way, but the fault here is vertical, but everything else is same, because the beds are actually dipping here in the same manner as we have in our figure. So if I just happen to fault it or have a fault in it, which is again we can say, although it's a vertical fold, I cannot certainly say that it's a normal or reverse, but if even the motion is in this sense, which we have in our case, you can see the after erosion, after faulting, we reach to this figure 2, and once this foot wall is being eroded, you can easily see that there is this slight offset on the map view due to this erosion, which we also observe here. So hence the correct answer here will be normal fault. Now the only confusion here can be between strike slip fault and normal fault, but it cannot be a strike slip fault, because if it would have been a strike slip fault, this offset which you get here in the cross section would not be possible. There will be just offset on the map view and not in the cross section view. But the correct answer here will be the normal fault. Moving forward, we have an AFM diagram in which 4 paletic assemblages are given, and it has been asked that which combination of these assemblages contain the same mineral phases in equilibrium with the staurolite zone. Now it's a quite good question, we can say. The question mentions that we are in a staurolite zone. So when we say staurolite zone, this is the Barrovian zone we are talking about, in which staurolite must be present in all of the assemblages. You pick up any rock, no matter where, from where, staurolite will always be there because it's from the staurolite zone. Hence, any mineral assemblages X, Y, Z or W, you should have staurolite. Hence, this tie line you see separating staurolite and biotite is actually not possible, and this is the catch here, that we have to rule out this tie line, or we have to actually assume the tie lines based on the condition given. The only tie line possible here is this vertical one, which is actually separating garnet and chlorite, because based on the temperature and pressure you might find chlorite in one assemblage and garnet in the other. So first thing, this, that there is no horizontal tie line, there is just one tie line. This is something we have to assume, or we have to identify based on the condition. So we cannot blame the examiner that they have confused us or they have given the wrong information here. Now again, now the next question that it asks, now the question becomes very simple. It just asks the assemblage that contain the same mineral phases. Now if I talk about X, so X would contain staurolite, garnet and biotite, and at the same time W will also contain garnet, staurolite and biotite. So I can certainly say that X and W are the phases or assemblages which have same mineralogy, and similarly Y will contain staurolite, chlorite and biotite, and so does the Z. So hence the correct answer here will be Bombay, and the catch in this question was that there is no horizontal tie line, there is just one vertical tie line which is separating the garnet phase with that of the chlorite. I'm repeating this again, because we are in the staurolite zone, we cannot have this horizontal tie line which separates staurolite and biotite, because if we have this horizontal tie line here, then W and Z would never have staurolite in them, but all of these are in equilibrium in the staurolite zone, hence they must, or they have to contain staurolite. I hope this is clear to you. Hence the correct answer here will be Bombay. Next is from the IUGS classification of rocks. You have 4 rock types and their respective mineral assemblages. So I have put a few of these diagrams which will make this question very simple to you. So larzolite, we can start from the ultramafic rock, is containing olivine, OPX and CPX, so I can clearly relate larzolite to 2. Then I have diorite. Diorite is something, it's a rock which contains plagioclase and some dark minerals, mafic minerals such as hornblende, so I can relate diorite to the plagioclase, hornblende and quartz. Tonalite is something which contains quartz, alkali feldspar and plagioclase, so tonalite should be, no, not that, it should be quartz, plagioclase and K feldspar. And norite on the other hand is something which contains plagioclase, OPX and CPX, so it should be 1. Now the sequence you can see 3, 4, 1, 2, which is option number C here. Next, match the mineral deposit types with the water types considered dominantly responsible for their origin. So it's a very straightforward direct question, and I have put these tables from one of the renowned books in economic geology. So here you can easily find the answer of this question. See, porphyry copper deposits, they are pretty much evident in the mid-oceanic ridge or magmatic environment, hence they are supposed to be found from the magmatic water. You can see that here as well, the porphyry copper deposits. Similarly, the MVT type deposits, which is a sedimentary deposit, is found to be formed from the connate or fossil water or brines which are abundant in the salt content. So I can see MVT or Mississippi Valley type deposits forming from the connate water. Then there are roll front uranium deposits. These are deposits which are found in underground or confined between 2 impervious layers, so they are formed or found to be formed by the groundwater. And epithermal gold deposits from the meteoric water, as you can see here. So the correct answer here again will be 3, 4, 2, 1, which is C. Next is there are few minerals and their optical properties are to be matched. So sodalite is an isometric mineral, so hence it has to be isotropic, because all isometric or cubic crystal system minerals are isotropic. Tourmaline shows pleochroism from blue to green. Calcite is a very prominent mineral which shows twinkling effect because it has relief in multiple directions. And muscovite is something which shows the mottled extinction. So in this question, even if you did not know about P and Q, from R and S I think you would have been able to solve this question. So the correct answer here becomes option number B. Next is the contact between the Talchir formation and the underlying Precambrian basement. Now it's a very good question. Talchir actually marks the beginning of Gondwana rocks, which are tillite beds or sedimentary in origin, we can say, and the Precambrian basement. So Precambrian basement, everywhere in the peninsular India, if you find a Precambrian basement, it's always a hard rock, either igneous or gneiss is metamorphic rocks. So an unconformity separating a hard rock from that of a soft rock or sedimentary rock is always a non-conformity. So it's a very logical question here, and by just giving this much information you could not even tell different type of unconformities. For angular unconformity, you must know the relation between the overlying and underlying bed, which you cannot tell from here. For disconformity, there is no information as such, and for paraconformity, both of the beds should be plane, or it should just show the time difference and not the erosional, or we can say non-depositional time. It's just a time hiatus of non-deposition. So the correct answer here will become a non-conformity. Actually it can be a para-unconformity, it can be a different type of unconformity later on, but the major or primary one will be a non-conformity based on the given information that a sedimentary bed is underlain by hard rocks. So the correct answer here will be D. The next is increased diversity of siphonate bivalves which have siphuncle occurred in response to. So it is supposed, or it is most appropriate to say that it was due to the Cambrian explosion, because they had this tendency to search for the food, and they grew, or they had this siphonus or siphuncle on their body, so they could go deep inside and feed themselves and can come up. So just in the search of food, they had this diversity, and it can be related to the Cambrian explosion in the Paleozoic era. The next is index fossil should have. Index fossil are something which can actually, or which can specifically tell you about the particular rock or particular stratigraphy. Hence they should have a large geographic range and small temporal range. They should not be having a large temporal range, otherwise it would be very difficult to find all of the fossil in just one stratigraphy or one strata. Hence the correct answer here will be A, that they should be present globally all over the world if possible, and in just one small time period. For the best example, we can say trilobites. Trilobites have, we can say, a large range from Cambrian to Permian, but that can be one example, because they have a very limited or very restricted type of temporal range. So the correct answer here will be A. Next is from the stratigraphy, we have few formations here and they have to be matched with their respective time. So Serengithorus limestone, it comes from the Kashmir area and also the Paleozoic rocks of Kashmir, so they belong to the Carboniferous. Karai shale, it belongs to the Uttatur group, which is coming from the Cretaceous of Trichinopoly, so I can relate it to the Cretaceous age. Chari is from the Jurassic of Kutch, so I can relate this to the Jurassic time. And then the barren measures, which are from the Permian and which we can say middle Gondwana, hence it is Permian. So the correct answer here will become 3, 4, 2, 1. which is option number C. And the last MCQ you have is which one of the following is correct. Now it's all based on the different bonds between different minerals. So the most appropriate option I feel here is option number D, in which it says metal sulfide formation does not involve splitting of d orbitals. So metal sulfide have strong ionic bonds and they can easily transfer electrons, so they do not need to have splitting of d orbitals. Hence this seems to be the most appropriate answer. If there would be any correction, we will correct it as soon as possible. So this was all from me. I hope I could satisfy all your doubts in this video. Try to reach out to us in case of any doubts and give your experience in the comment box, that how did you feel about the exam. So stay tuned to Geology Concepts and all the best. Keep learning.